So we want to find a point x and y, an ordered pair that's going to make both of these equations true. And so what we're going to do is we're going to graph both of these lines. So if I graph that first one, 1, 2, 3, it's a nice visual representation. It's not the most practical, but it's nice and visual. So this has a y-intercept of 3 and a slope of -5/3. So I'm going to go down 5 over 3. So from that point down 1, 2, 3, 4, 5 over 1, 2, 3. And I want to go as far as I can and make my line as neat as I can when I'm trying to actually find an ordered pair. Because I am actually looking for a point. I can talk. And so this guy here, so every single point on this line will satisfy that equation. It's pretty darn cool. If you plug this 0.3, -2 in there, it'll satisfy that. But we also need to satisfy this guy. So this guy has a y-intercept of -3 with a slope of 1/3. So I'm going up from that point, up 1 over 1, 2, 3. And oh, hey, look at that. This line looks like that. And I can see they intersect right there. So that point, that -3, makes both of these equations true. It lies on both of those lines. So that is the one point, there's only one point that makes both of those equations true, and this is it. You can always check it by plugging it in. So when the x is 3, the y should be -3. So the y should be -3. -3 equals -5/3 when the x is 3. So make sure this works. -3 equals, those cancel, -5 plus 3. And you can check your mistakes this way. That's a -2 on the y, right? Yes. So the y should have been a -2 here. Excellent. And so it's always good to check. And we have -2 equals -2, check. And it needs to work for both, so I check it in this one. So the y is -2 when the x is 3. So does -2 really equal 1 minus 3? -2 equals -2. Heck yeah, it does. Excellent. Let's do it again. For this one, let's see, graph the first line first, y-intercept of 3, slope of 4. So instead of going up 4 and over 2 where I run out of up 4 and over 1, I want to go down 4 and to the left 1, because that also equals nice and positive 4. -4 divided by -1 is still positive 4. So I'm going to go down 1, 2, 3, 4 to the left 1, down 1, 2, 3, 4 to the left 1, and I can see when I connect my lines I will have that positive slope that I'm supposed to have. And got that line there. This guy here, I've got a y-intercept of -2 and a slope of -1. So I could go down 1, right 1, down 1, right 1, but I could also go up 1, left 1, up 1, left 1, up 1, left 1, and that gets you that line, and it gets you that point right there. So that point, let's see if I can do this right this time, -1 on the x, -1 on the y, should make both of those equations true. So let's check it. -1, does that equal 4 times -1 plus 3? Does -1 equal -4 plus 3? Yes, it does. It's got to make the other guy true as well. Does -1 equal a -1, so a positive 1 minus 2? Does -1 equal -1? Yes, it does. So that's the one point, only one point, that lies on both of those lines. And another way to solve this, like this guy here, they met at a perfect point, but later on, you know, maybe they meet at a fraction, and it's really hard to tell when you're graphing if that works. So if you're ever curious or if it's not working out right, solve it with substitution. I'm going to do another video on that later. But if y equals this and y equals that, then this must equal that. So if we do a bit of substitution here, 4x plus 3 should equal -x minus 2. and we solve. I'll add the x to get 5x. I'll subtract the 3 to get negative 5. I'll divide by 5 to get x equals negative 1. Yes, it does. And then the y, just plug it back in. Y equals negative 1 is 1 minus 2 is negative 1. So you can use substitution if your graph's not coming out right, or if you want to check it that way. And I think you can handle the rest on your own. This one sometimes throws people, but it's actually pretty nice. Y equals negative 1, y equals negative 1 down there, and also for every other point that I'm drawing here. And so that's y equals negative 1 there. And then this guy here, y-intercept of 4, 1, 2, 3, 4. And I'm going to go down 5 and to the right 2. 1, 2, 3, 4, 5, 1, 2. So this point there happened to run across it right away. Whoopsie, if I can draw a straight line. That point there is where they intersect. That looks like it's 2, negative 1. Make sure it satisfies both. It certainly satisfies the first one because the y is negative 1. And then for this one, does negative 1 really equal negative 5 halves times 2 plus 4? Does negative 1 equal negative 5 plus 4? Yes, it does. Excellent.